Good evening and welcome to Tinkering with Edkelar. I thought it would be a good time for another piece of tube equipment again. What is it? Well, that is exactly what I was wondering when I saw it on eBay back when I was looking for a few spare parts. It was listed as a Minitester, or more literally a small test device. Given the fact that I know the manufacturer, Loewe Opta, to be making radios, I assumed it was something to do with that. And indeed it is. This little box provides 3 functions for testing classic AM tube radio receivers. There is an AC voltage source for 0.6 volts, 50 Hz, give or take, which can be used as an audio test signal, a continuity checker, and an RF signal generator that has a set of fixed and 1 variable frequency at an adjustable output level. I only found out these details way later, but the look of the device alone made me buy it. So let's have a look at how it's put together. The case is a wooden box with a metal front panel. There's a piece of paper glued to the bottom which lists the set frequencies. Handwritten. Seems to be retro-calibrated. Anyway, as usual, all the components are mounted to the front panel, so unscrewing the box and lifting it off. One of the screws is already missing. The box has a metal bracket on the bottom. Judging by the size, I'm guessing that it was intended to hold a spare light bulb. Removing the knobs. I want to clean up the front panel and check all the components, so disassembly it is. Oh, there's a vacuum tube hidden within. What a cute little form factor. The first part to come out is the little bulb. Continuing with the other screwed-on components. Now pretty much everything is unscrewed, but the front panel is actually 2 sandwiched pieces of sheet metal riveted together and capturing all the nuts and the light bulb cover plate. So let's get these rivets out of here. There we go. Now I can get the remaining components off. Finally, almost everything is loose. Only the sockets are held in place with some bent over tabs. There's a breach in the first pair of sockets. Taking apart the selection switch. It seems that the leaf spring is missing a tab. And the potentiometer is next. The trim capacitor for the variable frequency range is almost stuck. Nothing to disassemble here. I just dab a drop of oil on the axle. And after a good clean, the potentiometer goes back together again. The selection switch is one of the most annoying designs I've ever seen. Add that to some of the wiring going through the switch and you can imagine just how fiddly the assembly process was. I considered making a new spring based on the broken off end, but the original seems to stay in place even like it is. Attaching the components back to the lower half of the front panel. According to the internet, the original device was supposed to have an EF12 tube, but mine has an EF13. Somebody must have replaced it. They are almost identical, but in the EF12 the suppressor grid is connected to the cathode internally, while the EF13 has it on a pin. I add a bridge wire to make the circuit equal to the original tube. New power cord, and since the device is using mains voltage within the circuit, I'll leave the earth wire floating. Just don't tell anybody. Doing a quick function check. While stuff is still accessible, looks good. The cover of the lamp is a piece of plastic film. I'm sticking it down with Kapton tape to make sure it stays in place. The front panel cleaned up okay. I'm putting the rivets back in. And the knobs. The wooden box looked a bit worn. I'm giving it a bit of sanding and a fresh coat of paint. The model plate was in bad condition. It seemed to have been painted over with the wood finishing first and then got scratched over time. I used a magic eraser to lessen the paint as much as I dared and went over the rest with a bit of black paint to hide as many of the scratches as I could. It looks a bit splotchy in the close-up, but at normal distance, it's pretty good. And adding the model number plate again. I had to snip off some nails. I couldn't find any that small. Now here's how things work. The tube is forming an oscillator together with the switched RC combinations selected via the selection switch. Note that there is no rectifier anywhere. The anode is directly connected to the mains voltage instead, so only half the waveform will do anything, and on top of that, the output will be following the mains frequency. This automatically gives an AM signal that has the mains frequency, 50 Hz around here, as modulated audio on it, or at least half of the wave. And this is how that sounds. The AC output voltage is derived from the 6-volt tube heater transformer with a voltage divider. Nothing fancy. The continuity checker feature is equally primitive. The heater voltage is put against one pin and the other pin is connected via the lamp to the transformer again. So, if you connect the two pins externally, presumably via the wire you want to check, the bulb lights up. This had the bridge connected to it, which turns the bulb into a power indicator of sorts. But that was a non-standard modification. And that's it. A rather simple testing device for a radio repair shop in the early days of tube radios. I hope you enjoyed this little episode. See you next time! Only the sockets are still held in place with some bent over knobs. Not knobs, tabs. Tabs.